Prior to the development of the robotic data acquisition system, manual data acquisition was extensively used. Such methods can be unsafe, not very repeatable, time-consuming, and tedious. Using manual scanning, engine speed is limited to 3,000 RPM light load. Even so, acquisition is not easy or pleasant. If high repeatability or high engine speed and power measurements are needed, a measurement grid is used to define the intensity probe position. The operator then leaves the test cell and the data is collected. The probe then is repositioned. This is a very time-consuming process. To overcome the drawbacks of the manual methods, Ford Motor Company has introduced a robot-based data acquisition system. Setup of the robot system starts on the Unix workstation. Project details are entered and communication between the various parts of the system are checked. Control is passed to the robot controller and the handheld teach pendant in the test chamber. The dummy probes are used to prevent damage to the sound intensity probes during the test setup. The teach pendant displays a series of questions which steps the operator through the robot setup process. The process includes specifying test parameters such as short or long probe, regular or irregular surface, point-to-point or local scan, number of rows and columns to scan, and the number of scans per test. Multiple tests can be entered during the same setup session and regular and irregular scans mixed. The position of the probe can be adjusted by hand for precise positioning if necessary. Upon completion of the setup, the test parameters are uploaded from the robot controller to the Unix workstation, which resumes control of the test. The surfaces which have been set up can be examined on the screen. This display shows one of the grids that has just been programmed into the test. The best check that surfaces are correct is to carry out a dry run. In a dry run, the robot picks up the specified dummy probe and moves through the programmed surfaces in scan sequence. We see the robot performing parts of a continuous scan, a point-to-point scan, and a local scan. During the dry run, the scan time is recorded and sent to the data acquisition software to set the measurement duration. When the dry run has successfully checked the measurement surfaces, the NVH data acquisition parameters are entered. Ford's standard data collection software is used to enter parameters such as frequency range, microphone spacing, barometric conditions, etc. These may be entered individually or a preset test configuration file recalled. After the dry run is completed, the actual data acquisition can be started. The robot picks up the specified live probe and performs the data collection sequence. The collected data for each test is stored complete with its setup parameters for subsequent post-processing. Tests can be recalled and rerun without repeating the whole setup procedure. Test changes can be accomplished and conducted from the keyboard. For example, the robot speed and number of averages can be modified, and the new test then run without entering the test chamber to use the pendant. With the robotic data acquisition system, Ford Motor Company is safely collecting accurate, repeatable acoustical data on its powertrains over their whole operating envelope. This data is being used as part of a continuing program to improve the NVH performance of its vehicles and so produce better products for the customer.